Well, my name is Rui. I'm a solution architect, and today we're trying to talk a bit about BGP for multi-cluster connectivity in cloud environments. Obviously, this can be translated to any kind of environment you have. It can be an on-prem. The idea here is to give you an example. Obviously, we only have 25 minutes, so it will be a 10,000 feet overview, or probably I will try to do a walkthrough very quick about one of these examples. But I have included some links in the presentation that you can download. If you go to the QR code, I guess anyway you will get the presentation after. Which more other kind of deployments that you can test yourself. There are a couple of Git repos there. So before I start, why you would like to use BGP? These are some of the example use cases. For example, if you're using Egress Gateways, will allow you to map IP addresses to, of your deployments, for example, or namespaces in the exterior. So you preserve the context of Kubernetes to, some legacy device that doesn't understand that. It only can handle IP addressing. So obviously, you always can NAT the traffic with your Kubernetes nodes. But the problem is that if you want to expose that IP address of the Egress Gateway outside, obviously you need to know to which node return the traffic, right? So if you need to return the traffic to a specific node, likely you would like to advertise that to the underlying network, right? So that's one of the major use cases of using BGP connectivity to the underlying network. Another one is exposing services that do not support an ingress controller. Imagine you have traffic that is not HTTP or HTTP based, so you would like to advertise those services by means of BGP. You can, and you can get that traffic directly into the node. Obviously, you may say, well, I can do node port for that as well, for that matter. I can have a node port, a service exposed to the node port, and my load balancer will get there eventually. The problem when you use node port, and I won't talk again about that, Thomas did, that is you have double NATing, right? You have a NAT of your destination service, and you have a NAT of the source NAT of the node, because you want to force the traffic to go back. And that's something you can solve with eBPF, obviously, but well, that's something that you may take in consideration if you want to expose those services directly, right? So those are use cases. When we talk about connecting multi-clusters with Calico, there is another big use case, right? Unfortunately, this is not available in open source, but this is an example of what you may want to do, and that's service discovery. So imagine you have two clusters, you have production, staging, and you want your staging environment to be able to access endpoints that are in production, but you still want to use your network policies for that, right? So you need to use the labels of the remote cluster as destination of your traffic or source of the traffic, depending on what you want to do. And that's something that we can do if the cluster have connectivity. That's what is in policy federation or endpoint federation. And the service discovery or service federation is, imagine you have a kind of an umbrella service, and you want to redirect the traffic to both clusters. So instead of having endpoints directly to that service as a backend, what you have is other services. So you have a service that have multiple services below, and those services can be living in different clusters, right? So that's a very huge use case for this. Obviously, there will be others, but and that can be done in two different modes, right? You can use an overlay. Calico now supports an overlay that can do that through VXLAN. So imagine you will have the overlay across the two clusters. So that's the easiest way to do it. And you have BGP peering. VXLAN is not intended to be part of the presentation. In fact, we don't have too much time. Sorry if I rush a bit, but I need to be tracking a bit time because. But we will be talking about how to do it with BGP peering, right? So, next slide. So basically, you have multiple connectivity options. I will only touch one of them as an example, because the idea, when you walk out of the door today, the idea is you have in mind what you are be able to do with Calico, what you can do with Calico, right? So I will be choosing probably Transit Gateway is the deployment that I have in my lab. But well, there will be other other services that AWS, for example, will provide, like Direct Connect, if you have on-prem and you need connectivity to your cloud clusters, and there will be other VPN services as well. I won't be touching Azure, but if you want to test this yourself, I put a couple of links. One is a repo that pretty much is the same, but using route server, Azure route server, in order to connect the clusters. You can do it yourself later if you want. This is a blog post. Again, my colleague Jonathan Savo, which is a principal solution architect as well, he made both of them, are great resources if you want to look at those later. So I will just go do a walkthrough using the transit gateway as an example of how to use Calico in order to connect multiple clusters. In this particular example, I use EC2 instances using kubeadm on top of them. The reason why is because transit gateways are really tricky to connect because they need very specific things that you need to configure in order to make that work. And one of them is that the interface that you need to use to connect is a GRE interface, right? So for me, it was much easier to use a kubeadm cluster where I can modify the EC2 instance. If you're using EKS, probably will make sense to do this connectivity using other methods like Lattice, or they have specific services that will allow you to do that as well, and you can use Calico on top of that to use the micro-segmentation as well. In this case, I used kubeadm. So essentially what I am using is I'm using that GRE interface just to send the updates to the transit gateway. I have two VPCs. One VPC is using 172.16, the other VPC is using 172.19. And basically, I want to keep the connectivity of the VPC in the VPC route table, right? So I am using the GRE interface just to tell the transit gateway, these are the blocks of pods that we use in this cluster. But I do not want to use this interface for my connectivity. I still want to use the route table. And that's the reason, in order to make this work, there are several things that you need to do. But one of the main things is, let's say you have your route table. The route table will say any traffic that goes to internet, go to the internet gateway, if it is a public cluster, obviously. Everything that is local will remain local, obviously, and everything that is RFC 1918 or private addressing, I will have 3 routes that will go through. Anything else go to the transit gateway. The transit gateway will know how to get there, right? And the benefit of doing this as well is that you keep the BGP information as a minimum in the local cluster, because the local cluster only needs to know the other nodes that are part of that cluster, the BGP connectivity among them. Everything naturally will go through the transit gateway, everything else, right? So it's probably I'm not saying this is the best design, but it's what I would consider is probably the easiest and best design in this particular situation. So that's pretty much the context. Let's talk about a bit how to make that connectivity work. Sorry, but even before that, because probably I will make reference to this, but Calico, Reza talked about the architecture this morning. Calico has several services running inside Calico Node, which is the core component of Calico that runs as a daemon set in the Kubernetes cluster. And one of those services is BIRD. BIRD is the BGP daemon that we use is optimized for low resource consumption. If you Google about BIRD compared to other open source solutions as Go BGP or FRR, which other people use as well, this is really solid and probably in terms of performance is the best one in terms of performance, at least what I have seen. And it's used by the major internet exchanges in the world, right? They are using BIRD. Probably I will do. I will show you something related to the troubleshooting when you are trying to troubleshoot this solution, right? When it comes to BGP configuration, I won't enter into the details of it because it's really, we really don't have too much time. But just, there are several resources that you can use in Calico in order to control the connectivity, right? You will have your BGP configuration. The transit gateway can allow you to connect as an eBGP or eBGP peer, internal or external, but there will be conditions for that connectivity. For example, if you connect as eBGP, one of the requirements for them to accept your routes is that you need to prepend your AES path inside the update, which is something that you in the IBGP connectivity won't do by default because you don't want to, you won't prepend your local path, right? So at the end, that's the first thing. If you use eBGP, there will be other conditions that you need to meet. In my case, I use eBGP because for me it was easier to do it like that, and I will explain now how I did it. But well, you can control all the AS number, all the major configuration through a resource, which is called BGP configuration. Then you have the peer, right? I will talk a bit about the peer from top up. So one thing that you see here is source address known. The reason I use source address known is because imagine you have Calico. The way Calico works, probably I should start by that, but you have an IP pool. Calico will be the IPAN solution for your pods. It will give you IP addresses. Basically, the idea of this is you will do your peerings through this resource. The reason I use source address known is because imagine you have your Calico local cluster, all these nodes will be talking each other, right? So as we were saying, you have an IP pool where you will assign addresses to the pods. The way the IP pool, I don't know if you're using Calico, but the way IP pool is divided is in blocks. So imagine you have this full, CIDR in which you have like 65,000 IPs. Basically, you divide that in blocks. By default, it's a /26, which is 64 addresses each. So imagine every time a pod is initiated in one of the nodes, the node will reclaim a block from that IP pool, and that node will advertise that to the other nodes in the environment, right? So that's the local connectivity of the cluster. So you will like to preserve the IP of the node as the Calico IP to advertise, to do those advertisements, right? But what happens when you talk through the GRE tunnel? The GRE tunnel uses a specific IPI auto-assigned address range. This is not something that I choose to use. This is something that AWS imposes on you, right? So you will still want to use 172.16, for example, as your BGP router ID, BGP address to connect locally in the cluster. But when you connect to the transit gateway, you will use what the interface that is closest to this destination network. So you will use a 169 address that is part of the GRE tunnel that you have in that node. So that's the reason you use source address known, because Calico will use different IPs to connect to the peers. That's the way you tell Calico, just use the closest IP to your peer in order to peer. Another thing that you need to use is keep original next hop. And why is that? Because if we go back, what we want to do is just advertise the blocks, the range that I have here, and I want to use the node IP as the next hop of my traffic, right? So you keep the next hop with that stanza, right? And the last thing that you can see here is that I'm using a different AES number, so I'm doing eBGP peering. And likely I will have a filter here. And why is the reason of having this filter? This filter references to another resource that is a BGP filter that essentially has only one import statement that says everything that comes from the GRE interface, just filter that. And the reason why is because, again, Calico all the clusters will be advertising these /26 blocks to the transit gateway, but you still want to use the local VPC routes. You don't want to learn anything from the transit gateway. You just send whatever is not local to you to there, right? So that's pretty much the configuration. And the caveat here, and what I was talking about, well, transit gateway has very specific things in order to accept those connectivity. If you're using IBGP, you will need to prepend your AS number. If you're using eBGP, like in my case, the thing is that Calico by default, when it tries to connect to a peer, if the peer is in the same network as Calico, it won't use multi-hop. So by default, Calico does that by default. The problem here is that as I'm using a tunnel interface, I will have recursive routing, right? It will look to the destination is this, but it will need another interface in order to get to that tunnel interface. So I need a multi-hop connectivity. How I can achieve that if some parameter is not exposed through the resource? There are some custom parameters that you can do. Unfortunately, again, this is only available in the paid version. I mean, open source allows you to do all these resources, but for Transit Gateway, it will be kind of difficult because you won't be able to modify the template of BIRD. But in this case, you can use a config map and you can change that and you can make Calico behave the way you want to behave, right? So that's basically it. And let me show you a bit of how that's done. So you have this, this is one of the clusters, the 19 cluster. You have the other cluster, which is the 16 cluster. And for example, the config map that I was talking about, if I go to my config map, all spaces, that would be here is the BIRD template. So basically, this is the config map that I modified in order to make this connectivity multi-hop, right? So well, there is a line there that I needed to change in order to make it work as multi-hop. So in order to see how this will work for that federated sample, let's say, I have two different, well, even before I go there, just to show you one of the things that I mentioned is that you will need to preserve the next hop and all of that. One thing that you can do in order to troubleshoot this, if you go to the Calico node, we expose several BIRD parameters that you can query with Calico node status, which is a command line that Calico provides. But if you go inside the node, and I go to BIRD CLI, for example, if I do show protocols, I will see, for example, in this case, I have my two local neighbors connected, which are part of an automatic mesh that Calico does for the BGP connectivity, and I have the transit gateway connected here, right? So if, for example, I do show routes export in here, and I select one of these guys, so basically you see that this is the pool, the block from the pool that Calico is carving, right? So as you can see, is sending to the transit gateway that in order to reach this set of IP addresses that belong to pods in this cluster, you need to go to node 1.10, it needs to go to node 121 or the local node IP address, which will be this black hole route. Right? So basically, this is what I'm sending to them. I'm still preserving the local IP of the node, so the transit gateway will know that it needs to go to that route table in that VPC in order to get to that CIDR. As you can see, all the pods get the 245 address in this cluster. If I go to the other cluster and I see my pods here, for example, I see all of them, you will see that likely they have 10.246, right? So I use a different CIDR for my pods in the other cluster. And the transit gateway is learning all this information. If I go to the route table, this is the route table of my transit gateway. This is the transit gateway that I'm using. And you can see that it has direct connect routes to the VPCs, which are 16 and 19. It's connecting both VPCs, but it's learning the routes from Calico, right? These are the CIDRs that is learning from Calico from each of those nodes. I have 6 nodes in this case. It is learning one CIDR from each. And you can see the 245 and 246 in there. So just to give you an example on how the connectivity will work, if I go to services here, I have 2 services, right? So if I switch back to the default namespace, I have this service that is cluster B, and I have another service in here, service in the default namespace that is cluster A, right? And I can see, you can see that that service is exposed in both clusters. For example, I will go to one of those services. This is cluster 1 only, bigger, but as you can see, every time I refresh, I will get to cluster 1 only. If I see the endpoints here, you can see that the endpoints for this service expose, let me go back. This is the name of the service, cluster A expose. That's the service that I just accessed. So if I go to the endpoint, this is the local endpoint, right? So the local endpoint will be 10.245. But you can see that I have another service, and this service is having 2 endpoints. One endpoint is in the local cluster, while the other endpoint is in the remote cluster. And this is what I was talking about, the federated service. If I describe this service, you will see that this service has not a selector in the term, it has the, well, it doesn't have a pod selector, basically. So what I do in order to make that service to select those endpoints is that I have this annotation. So it will look any service that has this as the endpoint, label it as this, and it will add that service as endpoint for this federated service, let's say. And that's the reason I have endpoints on both of these clusters. I have an ingress controller that is exposing that. So if I, ingress class.ingress. So if I go to this ingress, well, let me show you that. But this basically is having the Nginx federated service as endpoint. So if I go to this false, I should go to both of the servers. If I go there, you see that I go to cluster 1, but I go to cluster 2. So it's switching between the 2 services that are in order to troubleshoot, again, you can use several things to troubleshoot. Mainly, you will like to look at the Calico node will mount a partition in the node where it will, tell you, if there is a BGP connectivity that is having problems, any error, likely you will be able to catch that in var log Calico BIRD current. Obviously, you can do it in the Calico node itself if you want. And likely you will like to see what routes are being sent and received. Again, we expose a lot of the BGP status and other things with Calico node directly, but in this case, likely you will need to go into BIRD and see what is being received and sent in this case. And that's pretty much it.